Today, we will be learning about inverse of a function. Given a set of ordered pairs for the function f of x, 1, 4, 2, 7, 3, 10, 4, 13, we can find the inverse of this function by simply interchanging x for y and y for x. The inverse of the function f of x is 4, 1, 7, 2, 10, 3, 13, 4. Notice our x and y values, they switch places. The inverse of a function, f of x, is written as f raised to the negative 1. The inverse of the function g of x is written as g to the negative 1. Please note, a function has an inverse if and only if it is 1 to 1. In other words, by inverting the x and y values of the function results in a function if and only if the original function is a 1 to 1. Let us look at a few examples. In this example, we have a 1 to 1 mapping where the values in our domain are 3, 5, and 7. The values in our range is 7, 11, 15. 3 maps onto 7, 5 maps onto 11, and 7 maps onto 15. If we switch this, will we get a function? Let us see. Our domain now becomes our range, and our range now becomes our domain. We have a 1 to 1 function. So if a function is a 1 to 1 mapping, then its inverse is a function. Let us look at another. This is a many to 1 mapping where the values in our range, 3, 5, and 15, they are mapped onto one value in the range, which is 11. If we turn this around, will we have a function? Let us see. A 1 to many is not a function because our x values cannot be repeated. So 11 cannot go to 3, 11 cannot go to 5, and 11 cannot go to 7. So if a function is a many to 1 mapping, then its inverse is not a function. Let us look at this example. Given the function g of x is equal to 5x minus 1, we are to determine the inverse of the function g and the inverse of the function g of 9. Let us do the inverse of the function g first. To find the inverse of the function, we are simply going to reverse the order of operations. To do this, to x, we are multiplying 5 and then subtracting 1. So let us reverse this and see what happens. So to find the inverse of the function g of x, to x, we will, instead of subtracting 1, we will be adding 1, and instead of multiplying 5, we are going to divide by 5. This will give us the inverse g of x is equal to x plus 1 all divided by 5. Now we have the expression for the inverse of g. We are given an input value. So we know that our input value is 9. Therefore, x is equal to 9. We are going to replace x with 9 in the function g inverse in order to find the corresponding output for 9. Let us substitute. So g inverse of 9 is equal to 9 plus 1 all divided by 5, which gives 10 divided by 5. My final answer is 2. Therefore, when x is 9, y is 2. We can look at another example. So to find the inverse of a rational function, we are going to interchange the coefficient of x in the numerator with the constant in the denominator and change their signs. Simply put, we are going to switch the coefficient in the numerator with the constant in the denominator and change the signs. Let us look at the first one. The function f of x is 3x minus 5 all divided by x plus 1. We are going to interchange 3 and 1 and then change their signs. This will give the inverse of the function f of x is negative 1x, also known as negative x minus 5, all divided by x minus 3. Can you do the second one? Pause the video and try the second. Great job. Let us see if it is, we will get the same answer. Given the function g of x is equal to 4x plus 1 all divided by 3x minus 2, we are going to interchange the coefficient of x in the numerator with the constant in the denominator, meaning that they are going to switch places and then we are going to change their signs. Good job. Our final answer, the inverse of the function g of x is equal to 2x plus 1 all divided by 3x minus 4. 2 from 2. Go ahead, pause the video and try the third one. Absolutely brilliant. Good job. Let us see if it is that our answers are going to be the same. Given the function h of x, which is 3 plus 2x, all divided by 4x plus 5, the inverse of this function will be, before that, we need to switch the places of the coefficient of x in the numerator with the constant in the denominator. And remember to change their signs. Now we can write the inverse of the function h of x is 3 minus 5x all divided by 4x minus 2. Well done. Let us look at another example. If the function f is defined by f of x is 9 all divided by 2x plus 1, we are going to find the inverse of the function f, after which we are going to find the inverse of the function f of 3. So let us first find the inverse of the function of x. Pause the video, go ahead, attempt the question. Once you are finished, unpause the video and let us see if our answers are the same. Great job. Let us see if our answers are the same. We can rewrite the function f of x as 0x plus 9 all divided by 2x plus 1. Why do we do this? We need an x value in the numerator because we're working with a rational function. 0x means 0 times x, which is still 0. Now, we can interchange the coefficient of x in the numerator with the constant in the denominator. So to find the inverse, we will now have the inverse of the function f of x is equal to 1x plus 9 all divided by 2x plus 0, which is the same as x plus 9 all divided by 2x. Great job. Let us find the second part of the question. The inverse of f of 3. We know that x is 3, so we are going to replace x with 3 in the function f of x inverse. When we substitute, we are going to get 3 plus 9 all divided by 2 times 3, which is equal to 12 divided by 6. So my final answer is 2. Therefore, when x is 3, y is 2. Thank you very much, guys, for watching. See you in our next video.